In 2.2, we're going to be looking at some more graphs of linear functions, and we're going to look at some different information than what we did in 2.2 and in 2.1. And so I want to start here first with vertical and horizontal intercepts. When you're looking for a vertical intercept, you were looking for the Y-intercept. And so when solving for it, you want to set your x equal to 0 and solve it out. And so I would say plug in 0 for x and solve for y. And so your answer should look something like 0, comma, some value. Majority of the time you are going to be entering an intercept as an ordered pair because it's the placement on a graph. So just be aware of that and read your instructions as you move along. The other intercept we're going to look at is called the horizontal intercept or the X-Intercept. They're going to use those two terms interchangeably. So you're going to see some questions with horizontal, some questions with X-Intercept. When you're looking for the X-Intercept, you're going to set your y equal to 0. So you can see whatever one you're looking for, zero out the other letter. And so we're going to say plug in 0 for y and solve for x. And we do a whole lot of solving for x, and you know that because you've taken math courses before. So that one's going to be something we do quite a bit, is finding those x-intercepts. Your answer is going to look like something, comma, 0. We could have one x-intercept, we could have multiple x-intercepts, but again, know that when you're doing these intercepts, typically your answer is going to be written in an intercept in a ordered pair form. And so if you type in the answer and it gets it wrong, try it as an ordered pair with the parentheses and the comma. If that doesn't get it, feel free to shoot me a message and say, hey, I'm working on 2.2 number 3. I'm pretty sure my answer's right. Can you take a look at it? And I'll be happy to take a look at what you've entered into the online homework. So let's use this knowledge and these intercepts to help us to graph, because that's our whole point. We're trying to graph these things and whatnot. So it says graph the line and find the intercepts. Okay, so for this one I want to kind of split into two parts. I want to first find the y-intercept. Remember, we're going to be setting x equal to 0. And then I also want to find the x-intercept. So remember, we're going to have to set y equal to 0. And so let's just kind of apply what we wrote up top here. So I'm going to use my function here. Remember, when we're saying f of x, that's going to be our y value. That's just our formal way of writing the equation. So if I want to find the y-intercept, we're going to 0 out x. So I'm going to go ahead and write this as y equal to, instead of f of x, I'm just going to go ahead and use y, equal to -3 plus 1/2 times 0. Anytime I'm plugging in for a letter, you're going to see me write a parentheses and a 0 there. That's going to help me with my arithmetic, my calculations, make sure I don't mess anything up. Well, multiplying by 0, that just cancels, so I just get y to be -3. So again, I always want to write that as an ordered pair. We plugged in 0 for x, we got -3 for y, so this right here would be my y-intercept. So over here on my graph, it would mean this point right here. Remember, this is your y-axis, this is our x-axis, and we're going to plot that. Now to find our x-intercept, we're going to have to plug in 0 for y. So I'm going to say 0 equal to, let's see, -3 plus 1/2 x, and then I'm going to solve for x. So I'm going to go ahead and add the 3 over. So it gives me 3 equal to 1/2 x. And then to get rid of that 1/2 being multiplied, I can multiply by 2 on both sides. Because that's like being divided by 2. So multiplying this 2, these are going to cancel just to give me an x. And then 2 times 3 is going to be 6. If you prefer that was 1/2 times x, you could divide both sides by 1/2 and you would still get 3 divided by 1/2, which just gives you 6. So as an ordered pair, that would be 6, comma, 0. So that would be my x-intercept. So I'm going to come over here, 1, 2, 3, 4, 5, 6. And I can put a dot. So just by using my x-intercept and my y-intercept, I now have the way this line looks. Now, I know you're a smart individual. You're enrolled in a pre-calculus course. Looking at that equation, that's just like what we did in 2.1. You could have graphed that without finding these two pieces of information. But I want to show you what this looked like so that you know what the graph is supposed to look like based off the previous section, but you understand how we're getting these X and Y intercepts and how those two graphs are the same. Because not all the equations you're going to work with and finding X and Y intercepts are going to be as easy as that equation that was given. But I want to review, go over, and remind you of these processes. And so if we have our X and Y intercepts, let's move on and let's look at our horizontal and vertical lines. Horizontal and vertical lines are really nice lines because you can graph them really quickly. This goes back to what we were doing when we were talking about slope. So just a couple of reminders. When you're looking at a horizontal line, that is going to be when your slope is 0. And so when your slope is 0, you have y equal to 0x plus b. But anything times 0 just zeroes it out, so that part would go away. So we really just have y equal to b. So all the equations of our horizontal lines are going to be y equal to some number. And so here's a little example here. If I want to graph, say, y equal to 2. I'm going to go up to where y is equal to 2. That would be right here. And I could just go to the left or right of it a couple units. And so this would give me my horizontal line at y equal to 2. So all your horizontal lines have a slope of 0. All your horizontal lines have an equation of y equal to whatever that y value is that all those points share. Now your vertical line, a couple of reminders, this is when your slope is undefined. Now it'd be a bit ridiculous for us to say y equals undefined times x plus b. Like no one wants to do that. So let's kind of think about this. If a horizontal line is y equals to some number, then our vertical line is going to be x equal to some number, say c. So an example of this, let's say x was equal to 2. And so that means I'm going to click right here where x is equal to 2. And then I could just go above it. I could just go below it, get a couple points there. And then here would be my vertical line. So this would be my vertical line. Its equation is x equal to 2. Don't let that fool you. And this is my horizontal line. Its equation is y equal to 2. Don't let that fool you. And just kind of remembering back to having that vertical line, remember, this is not a function. It would not pass that vertical line test. So all those vertical lines have a slope of undefined, and they are not a function. And so as we began to look at these linear functions and we're graphing them, we're looking at their intercepts, we're looking at horizontal and vertical lines, this leads us into a conversation of comparing lines. And so we had this idea of parallel and perpendicular lines. Now if you think about parallel lines, I always kind of have flashback to driver's ed, talking about parallel lines or parallel parking. When you're parallel parking your car, you're parking it next to the curb, not with one wheel up on the curb, not cutting through it. And so you don't want to intersect that curb. So parallel lines never intersect. Now it would be a waste of our time to go to a graphing calculator, because we're not going to use those, and to graph all of our lines and stare at them really hard and say, do they intersect? And that would not be the best approach or most efficient approach to that. So how could I tell if two parallel lines never intersect? We're going to do that by looking at their slopes. And if they're parallel, they're going to be the same slope. They're going to be rising and running at the same rate. And so knowing that they have the same slopes, we're just going to go back to what we were already doing with some linear equations. And it says find a line parallel to... So here's what I want it to parallel to. F of x equal to 6 plus 3x that passes through the point 3, 0. So let me just say right now, if you don't use any of the numbers written in this problem, you're not on the right track. If you don't use that green equation in some way, pulling data from it, you're not on the right track. If you don't use this point, 3, 0 over here, you're not on the right track. Now, in that equation, I want a line parallel to that. So really, all I'm going to use is my slope. So I'm erasing some green here. I'm really only going to take the 3 from that, and that's the only information that I want to pull. And so since this line has a slope of 3, I want my line to have a slope of 3 because they're parallel. So there's my slope. Here's my point. That's my x1 and my y1. And then I can just follow suit from what we've already done. So I'm going to say y minus y1 is equal to m of parentheses x minus x1. I'm going to write my point slope form. I'm going to rewrite it with those letters missing. And then I'm going to plug in everything I know. So I want it to be parallel, so I want it to have the same slope of 3. x1 is going to be 3, and y1 is going to be 0. Well, this looks out for me because y minus 0 is just y. Distribute. That gives me 3x minus 9. And there's my equation of a line. So for this problem, you would have to know that they're parallel means same slopes, and then you would have to create that line. Don't try to shortcut. That doesn't take you very long, what we just did. A lot of students want to grab in there and go, 3, 3, and they make this new equation, but they don't work it out and realize that really the y-intercept is minus 9. So be careful with that. Go slow, show your work. Anytime you're taking an exam, you must show all your work for a problem. No work, no credit. So slow down, write it down, show me what you're doing. So if a parallel line never intersects or has the same slope, then we know perpendicular lines intersect. But they intersect really in a special way. Perpendicular lines intersect at a 90-degree angle. But again, you know what? Math people are actually kind of lazy. Like, we like formulas because we don't want to reinvent the wheel every time. We like working with variables because we want to solve for an unknown quickly without having to say, how many widgets do I have? How many shirts do I have? Etc. And so, you know what? Perpendicular lines, I really don't want to pull out a tool and measure the angle between two lines at their intersection every single time. So I'm going to use something to help me with that. So let's think about their slopes again. And how can I get it to perfectly intersect at that 90-degree angle? Well, what we're going to see is that the slopes are opposite reciprocals of each other. Opposite reciprocals of each other. And what does that mean? It means that if I had, here's a little example, say I had a slope of 4 and I wanted something to be perpendicular to it. Let me give you some better words to go with that than just opposite reciprocals. If your slope is not a fraction, put it over 1. What you're going to do is you're going to flip it to 1/4 and change its sign. So if one's positive, the other one's negative. So opposite reciprocal, flip and change its sign. So again, let's do an example and work with that one. It says find a line that is perpendicular to this equation and passes to the point 3, 0. So same equation, same point, but now I want it to be perpendicular. So if this slope is a slope of 3, we don't want to use that. We want to put it over 1, and the one that would be perpendicular to it is flip it to 1/3 and change the sign to negative. Now that is going to be the slope that we use. That's our m of our new line, and still here's our x1, y1. So I'm going to say y minus y1 equal to m of x minus x1. So it's going to be y minus equal to parentheses x minus. So my m is going to be negative 1/3. My x1 is 3. My y1 is 0. Again, solving that, so I'm going to distribute. It gives me negative 1/3 x. Negative and negative make a positive. 1/3 times 3 gives me 1. And then y minus 0 is just y. So I quickly created a line that was perpendicular to the one that was given and going through the point 3, 0. Again, show your work. Go slow. Don't speed through it. I understand some of you are very smart and that you work through a lot of math in your head, and that is great. But you need to show it on your paper what's going on in your head, not a mind reader, so I can kind of follow along and give you as much credit as I can. I want to give you full credit, but maybe you missed something along the way. I can give you partial. So parallel, we're going to have same Slope, perpendicular, we're going to flip it and change the sign. And then let's talk about intersecting lines. When we talk about intersecting lines, we are talking about lines that intersect at one point unless they are parallel or coinciding. Meaning same lines. We're no space there. Sorry about that. And so let's look at this one. It says find the intersection of these two lines. And so we're not talking about parallel. We're not talking about perpendicular. We're talking about finding where two lines intersect. So for us to find where two lines intersect, that means they share an ordered pair that they have in common. So the first thing we're going to do is we're going to take these two lines and we're going to set them equal because they're going to be equal at that one point. And so I'm going to say 3t minus 4 is equal to 5 minus t. And I'm just going to solve for t. So I'm going to get all my t's together. So I'm going to say plus t. This gives me 4t minus 4 equal to 5. Add the 4 over. It gives me 4t equal to 9. And divide by 4. So t is equal to 9 over 4. So t would just be the first value of where these two intersect. And then if I want to find the second value of where they intersect, because right now I just have 9 over 4 for that first ordered pair. So for part 2, I just need to plug it back into one of my previous equations. And I'm going to plug it actually into that j of t. So I'm going to say j of 9/4 is equal to, I'm going to use some arithmetic here. This would be 5 minus 9 over 4. Change this into like fractions, so that's 20 over 4 minus 9 over 4. Combine that together, it gives me 11 over 4. If you're not very good with fractions, use your calculator. Do 5 minus parentheses 9 over 4. Change it back into a fraction, and 11 over 4 would be correct. Always like reduced and proper fractions. So what's happening is, let's kind of graph this out. H of t is 3t minus 4. So I'm going to take h of t, I'm going to graph this. So this would be 1, 2, 3, 4. There's my y-intercept. Slope is 3, so 1, 2, 3 over 1. Let's see, 1, 2, 3 over 1, 2, 3. Just trying to get a lot of good points here because I'm not sure where these two lines are going to intersect. I don't want to miss it. Well, actually, I know where they're going to intersect. They're going to intersect that ordered pair I have written right there. 9/4 and 11/4. And then let's graph the other one. Let's see, that would be at 5. So 1, 2, 3, 4, 5. And then down 1 over 1, down 1 over 1. You can graph a line here. And so we can see that here is our j of t line. But you can imagine the trouble it could be to find this point right here on a graph looking at it. We're not going to use our graphing calculator to intersect them. We're going to use our algebra skills here to find that. And we can find the exact answer to be 9 over 4, 11 over 4. So 2 steps. 1, you're going to set the equations equal, and then step 2, you got to plug it into the other one of the equations because it's going to work for both of them. So I hope this helps you as you're working through your 2.2 section. If you have any questions, comments, concerns, or you get into the homework and you need some further explanation, feel free to reach out to me.